All right, we're back with the New Stack Agents, our show about all things AI. And as so often, with me today is Alex Williams, co-founder of the New Stack, and Keith Ballinger, VP and GM for Google Developer Experiences. That's a mouthful.
Yeah.
And thank you both for being here.
Yeah, it's my pleasure.
Good to
Absolutely.
see
Now,
you
before we get
both.
started, Google Developer Experiences. That seems like there's a lot in that. Can you talk
Yeah,
just for a moment before we get
the
started
the
about what
G
that all includes?
yeah the G actually stands for GCP, but funny enough, it
Oh,
does include a lot of non-GCP pieces. So I should probably rename it. But what the GDE org does is a bunch of developer tools and services. So there are classic tools and services that you use in GCP like Cloud Build or Cloud Deploy. But we also do a bunch of AI agentic coding tools as well. For instance, Gemini CLI, which is not a GCP only product. Essentially, and then like the Go team works for me. The people who run that project in the open source world, Flutter, Dart, the Google Developer Program that everyone should sign up for, and so it's a lot of Google's primary stuff when it comes to development. And of course, our big push these days and a lot of our focus is on agentic coding. How to make developers have a lot of fun using AI.
how do you keep all of that straight, and how do you balance this current push for AI with other projects like Go or Flutter or Dart, programming languages and other kind of primitives in the programming world?
I mean, it's a good question. I think one thing to think about is, in the end, AI isn't this incredibly separate thing. It helps with like all parts of building and operating code. And so in many ways, even when you're investing in something like the Go team, you're actually helping agentic coding as well. So for instance, the Go team has a lot of really great static analysis tools, an LSP. There's an MCP built on top of that to make it even easier to do Go coding when you're using Gemini CLI, for instance. And what's really nice is, those tools, whether they've been built now or have been built, in the past, it turns out that they're just still useful for AI. And so you don't have to always think about things as, I'm going to invest in something that's purely about AI coding or not. It's almost every investment can help both in a lot of ways.
Now, before we move on, I was just thinking about your history too, because you were at Xamarin, which some people probably don't remember anymore at this point. It's about 10 years ago or so. It was a big open source project. Xamarin, I assume you went over to Microsoft when Xamarin was acquired.
Yeah.
You went to GitHub, now at Google. Talk to me a little bit about your career path, how you ended up with this.
Of course. My first dev job was at Intel, and I was there for a couple of years in the late 90s. And then in 99, I joined Microsoft actually that time. And I spent 8 years at Microsoft, and about half that time I spent working on .NET and C#. So Anders Husberg, the creator of C#, he was in the office next to mine. And so I've always been in dev tools ever since then. And when I left Microsoft, I just started doing a lot of startups. I really had the startup bug. Those startups ranged wildly, because I wanted to get lots of experience doing lots of things. But the ones that were focused on coding and developers were the ones that I enjoyed the most. So for instance, I was the first employee of a startup called Standard Treasury, which was building APIs for banks, targeting developers. That was bought by Silicon Valley Bank. And, I did Xamarin, where it's really funny, actually. Nat Friedman, who's was the CEO of Xamarin, he asked me to kind of help him, he hired me as a consultant one day to help him find a VP of product. And, I kept trying, grabbing candidates and bringing them to him, and he kept saying no. And I was like on the side starting my next startup. And then I was unable to do that startup because my co-founder got sick, and I was complaining to Nat about it. And he's like, why don't you just be my VP of product? And that was a little surprising to me because I've been an IC product manager at times, and I've been mostly an IC engineer with a little bit of engineering management. And so I said, sure, why not? And then I read a lot of books about how to be an executive and a manager. Yeah, and then Xamarin was bought by Microsoft, and at Microsoft, I ended up being the general manager of developer services, which was things like Azure DevOps and the internal one engineering system, they called it. And then Nat and I got the bug in our ear to try to get GitHub bought by Microsoft, and so we wrote like a one pager that was mostly bullet points for Satya, and it went incredibly smoothly, I have to say. It was amazing how all the pieces lined up so easily. And then we moved over there, and Nat became the CEO, and I became the SVP of engineering.
It's a good fit because I was at the GitHub Universe conference. That's why I'm here in San Francisco in a hotel room, as I so often am for these recordings. And it was funny. I was walking through the startup hall there, and there was a lot of startups and companies in the ecosystem at GitHub, and there was Google Jules as well, which is not quite part of your org, I think. But
no, Jules it's a lab project. So Google Labs tries to do cutting edge, services and apps, and being part of research and whatnot. They kind of get to do like I said, cutting edge stuff, riskier ideas. And then traditionally, when Labs comes up with something that's really good, the tech or the thing itself or whatnot will transition into a product team at some point in time. And so Jules was like an example of, hey, what if we built something that was like tied to to GitHub, especially GitHub issues, and could do those, semi-autonomously. And it's been very useful to learn how to apply that kind of methodology and that tech to, our other products that we have free versions of, but also that we sell to people, including enterprises.
Yeah, and Jules now becoming with a couple of other projects like OpenAI's Codex and Anthropic's Claude Code.
I think Jules is a little
other ones,
Yeah, I think a little bit Jules differently than that. I think Codex has a CLI and a web version of the CLI, and Claude Code has the same thing. Jules, I think, is like taking a different approach where they're much more, they have a much more specific workflow around how you work with GitHub and GitHub issues and whatnot. The Gemini CLI is decoupled from Jules. It's not they're different projects, but the Gemini CLI will obviously also have like a web interface to it, like Codex Web and whatnot. Those are more general, right? They just kind of do anything.
I have a quick question.
Alex, jump in there.
I was just asking about, how, Keith, you really started to, unfold AI, so to speak. So how you started to really use it. Because you were saying before our recording, like a lot of people just don't know how to use it, and they're using it kind of in a very single shot kind of way.
Yeah.
What have you learned and about that, and tell us about those early days when you were first getting started.
Yeah. And it's interesting, while I've always been involved in like developer tools and technologies, as a teenager, I actually I was like an email pen pal of Marvin Minsky. And so I had the AI bug very early in my life. And, like I put together a hack team once, like 2012 or something for Bayes Hack, which did like, machine learning for things for nonprofits. So I've always been really interested in that world. And then at GitHub, we started building Copilot. And the idea there was, OpenAI had come along and finally had a pretty good model. That, funny enough, they called the Codex at the time, and it could do coding tasks pretty well if you managed it carefully. And so the very first thing we did actually was purely code completion. There was a chat soon, and interestingly, I think the code completion, starting with something very interactive, was very useful in understanding how people would use AI and kind of getting them comfortable a little bit with it. And then, of course, then people started using the chat, and some people go like a ChatGPT or a Gemini even today to do AI coding. And then, of course, like agents came along, right, where all of a sudden the model was doing things on your behalf with tool usage, and that was like a really interesting, growth in our industry. And I kind of followed along on it. And I remember like maybe mid last year, all of a sudden tool using models started really taking off. And so, you have things, people like Cursor all of a sudden were able to make a dent because they weren't just code completion and they weren't just chat. All of a sudden they were, like I said, like doing these kind of semi-autonomous tasks for you with tools. And it was funny because up until then, for like the year prior to that, I would just use chat. So I would go to Gemini, what we called Bard at the time, and I would tell it what I wanted to do. And then it would come back and like give me code, and I would take that code and I would paste it, into my project. But it would also tell me to do other things like, run a test and give it the output of the test. And I was basically acting as the tool for Gemini, for the model itself. And then once that was automated, all of a sudden you could do things so much more quickly, and it really expanded on what you could do. Now, it's interesting, one of the things you talk about is how people use it, right? And there, I think one of the things I'm seeing in the industry right now is there's a big variance in people understanding what the best practices are, and even maybe what the best practices, should be. And that's something I think that we have to kind of do more education to help people understand like how to use AI for assistance, for coding. Because if you just single shot stuff, you're not going to really be successful. You have to treat the AI, kind of like a coworker. And if you follow best practices from development in general, things like writing like a user guide or a spec, things like writing a technical design, creating a project plan, just those 3 things. If you do that when you interact with AI, which you should do anyways on anything complex, you actually have really great results with AI. And I can show you an example of that. Actually, I have a little open source project that does that, if you want to see.
Go for it.
Okay, cool. I will share my screen. Let's see here. So I just want to pull up the right thing here. So this is my desktop. Tell me if you see something called line counter there.
Yes.
Cool. And you can see right now I just have one file called conductor MD. And if you go to my GitHub, you can find a repository called conductor. This is a file that I use to set up a project. And the way that works is, I'll just cap conductor so you can kind of see what's in there. It specifies to the AI how to set up the project. And there's like a plan file, style guide for pros, style guide for code, a workflow, a status file, the prompt that you can use to launch the AI at different times, user guide, architecture, and then with more details. So what I can, sorry, go ahead.
So just to go in there, I saw a similar, this is your project, which is kind of interesting that you're coding yourself, obviously, but.
Yeah, and conductor is really just markdown files for what it's worth. Yeah, but yes.
Yeah, no, that's what I was thinking about. It's still all very verbose, and we see similar projects, right, where we have agents.md files.
Mm-hmm.
Do you think is that kind of just a step right now in a different direction where we don't have to do that anymore? Or kind of how do you see the future of that?
I hope not. I don't want to. I think I like creating, I like being a craftsman and creating things, and I want to be involved with that. I don't necessarily want to write every line of code and debug every test failure or whatnot, but I like the act of creation. And for me, the act of creation is thinking of a problem I want to solve, and then thinking about how I want to solve it. And I think those things, AI could probably do that as well, but you still have the problem of how do I as the AI or how do I as a human give you enough of like what I want without the AI, you have to do that somehow. It can't read your mind, at least not yet.
Mm-hmm.
And if it doesn't read your mind, then you can't get that. And I want to be involved in that part. So let me show you, I'm going to go back to that, my terminal here. And I'll just show you how this one works because it's manual to your point. There are MCPs that do this kind of thing. I like doing it manually because I find it to be more enjoyable. Plus I can really control exactly how things happen. So I can, and I just had this prompt ready to go. I'd like to build a tool, smart line counter, counts lines per language, prints out a Spark line or histogram. And then I just say, use the process outlined in conductor MD to set everything up. So it's going to read that file. And as you'll see in a second, it's going to set up a folder called .conductor. And it's going to put into that .conductor folder, say, yes, always. It's going to put like all these documents that really will help me and the model work really well together, like that architecture MD and the style guides and whatnot. And this means I can be involved in the parts of creation that I'm really interested in, without necessarily, having to do everything. And so, we can see it's now it's creating these. And one of the interesting things about this project, and again, it's just a project. I think the idea is what matters, is how you want to control the agentic experience. Okay, so now it needs to write the user guide. I could just write a user guide if I wanted to, but I actually have it ask me questions. And I won't go through all of this right now, but after I answer all those questions, it then has a very specific task plan and architecture doc and like user guide. And then I can come back anytime I want. I can do a session, I can do a couple tasks with it, where all I really need to say is what's the next task? And it'll continue on with that. But these are very detailed, which means, hey, we can achieve a lot of success. And I have using this methodology, whether it's with Conductor or just like similar tools, I've been able to build, I think, very interesting and complex things. So for instance, if you don't mind, I'll show you one of these. And I got really interested in languages. I've always been interested in languages, but I had the idea, and so I just wanted to prototype.
Programming languages.
Yeah, programming languages. So I got really the idea of like, could we build a programming language that was for LLMs? And one of the problems LLMs have is programming languages aren't, they're ambiguous at times and things like that. That's where a lot of the code generation tasks fall apart. So I created what is basically a really ugly language to humans. It's a Lisp, but it's like incredibly specific and doesn't have much ambiguity at all for the LLM. And I built this using that methodology I was talking about, and it's like a Rust project, right? So here you can see, this is all the Rust code. It's using Rust and the LLVM to compile essentially a systems language that is very, it's very fast and it contains a lot of capabilities. And I did all of this just with that methodology, creating an architecture, creating a plan and going through it. Anyway, if someone wants to check out this, I call it Aether. It's on GitHub under the Google Cloud organization. And I have no idea if it actually makes LLMs better. I haven't done that part. But what's interesting is this is like a complete language, and it works pretty well. All of those examples work. All of the tests pass, and there's thousands of tests. And I built it probably in a month, just some nights and weekends. And that's the interesting thing is if like you spend a little bit of time up front, you can just really, slow down to speed up, as they say. You can just get so much done.
So how do you then make sure that it's working correctly, and that, often when you put in a prompt, and then the output that you get from the prompt, and then you apply it maybe to your dev environment, it doesn't really work very well.
Mm-hmm.
So how are you verifying everything?
The way I do that is I use the AI to help me with that. So I don't look at every line of code. And with something like Aether, I don't really know Rust all that well. So it isn't like I would have, done a good job of that anyway. I know LLVM okay-ish, but I created, that architecture doc. I did collaborate along a lot with it. And then the task plan was very minute. And after each task, I basically had it do like a test-driven, it was like TDD. It would write tests, and then it would implement the feature until the test passed. So, I would look a lot at the tests, but I also spent probably most of my time looking at the examples. I had to create a bunch of examples covering all kinds of scenarios, file IO, HTTP, like a blog, simple, memory management things. And those examples I made sure always ran. So after any task that was done, I would make sure like the examples ran and all the tests passed. And I would make sure the AI was doing those things too. And so in some sense, it's a black box to me. All I really care about is, in the end, did it work? But at times I'd go casually inspect things as well. And as you can see, it's, perfectly fine Rust code.
So it's interesting because you've discovered some new experiences through all this, haven't you? And this came, but a lot of development comes from problems people have. I'm doing a little research on Jupyter projects, Jupyter right now, Jupyter notebooks, and just like a lot of things, it was like it came from a need, right? The files were everywhere. They couldn't keep track of things. They couldn't keep them updated. I'm curious about the experiences that have been troublesome for you in traditional development, and now how you're seeing them transform your own thinking about software development overall.
Yeah, that's a good question. I haven't thought about that actually. So it's a novel question to me. I do agree with you though. In general, a lot of the best software that's been created in the world came from some engineers' personal pain points, right? Linus Torvalds created Git because he needed better source control for Linux. I think it's a classic example of that. And it just had so many uses outside of Linux, right? And it changed how people in our industry worked in a pretty fundamental way, especially with like once you combine it with GitHub's pull requests. And I think about like the kinds of problems I have are, I generally speaking, I don't code a lot to solve problems. I code a lot to have fun, I guess is what it comes down to. If you think about business issues, because of like my position leading all these teams, I do want to use tools a lot to understand them and make sure the quality is high. So part of this is just dogfooding. I like to code a lot to make sure we're building high quality products. And then when I come across something like a best practice, then I'll hand it to the team. But at times I have ideas that I think could be applicable. For instance, I'm still writing an MCP server. I call it DevSense. I should probably call it something else, that essentially like looks at Git history and then does the same kind of analysis that the book Your Code as a Crime Scene does, where you can do analysis of like the tip of your source code, just like what it looks like now. But the much more interesting analysis oftentimes is how the code has changed over time. And so that was something I thought was very interesting. And so I, like I said, I started building an MCP for it. But yeah, a lot of stuff I do is just for fun. Like I built a comic book generator using Nano Banana. Because like I was like, oh, this seems fun. So like it lets you create reference images, and then you give it a comic book script, and it goes and creates the panels and all that stuff. And so that was like, that's the kind of thing. And I was inspired by that from my fiance, who like made me a comic book for my birthday. That was pretty cool. And it just got me thinking like, oh, how can we make this even better agentically? So the inspiration comes from everywhere.
As you're doing that, you clearly, you're really thinking about, not just one-shotting and other best practices, but where have you struggled so far with using these agents? What hasn't worked for you?
I mean, I think it goes back to actually the CLI. Before the CLI existed, or other tools like it, you had, I was saying, like the human had to be the tool. I would be told what to do, and then I would read the file and I would paste it into the chat or whatever. But when we decided to make the CLI, all of a sudden we had we solved that problem, and we made it like it wasn't as tedious or laborious anymore. And that was like, I think, one of the drivers for Gemini CLI or other tools like that.
Mm-hmm. Why do you think the CLI has become so popular again lately? We've got pretty much all of these agents have some kind of CLI version at this point. Why is that?
Yeah, I think honestly, we never abandoned the terminal. I think as part of it, we didn't think about the terminal as a primary interface more and more. I think people, you would go to the terminal to run things like npm, We're just other commands like ls or whatever.
Right.
But we didn't think about it as like our primary interface more and more. There used to be like a rich ecosystem of like TUIs, like terminal user interfaces, like Midnight Commander, right? And those are very
afraid
popular.
I'm old enough to remember that.
Yeah, right. And it's interesting. Like those are, we just like kind of stopped thinking about those and just had command line script. But we always use the terminal, and especially in modern development. Especially where there's so much OSS. Like people use the terminal for Git, and so it was really natural, I think, to use the terminal as a way to do these things. It gives you a lot of control. It focuses on the job to be done versus lots of UI, and so it kind of, focuses you in on what you need to do. And it just kind of follows along with what you're already doing or what you have been doing.
The CLI is an interesting topic now in the world of AI, as Frederic is noting. I'm curious about how you see the terminal itself evolving. I mean, the Gemini CLI brings AI directly into it, doesn't it?
Yeah. I think it's a really interesting question. Will the terminal evolve to be more AI capable itself, and or will there just be more and more AI capable or influenced command tools within it? Like a year ago, I built a prototype of kubectl. I built an extension for it called kubectl AI, and that was actually the team rewrote it because my code was awful, but it now it's not part of kubectl core, and you can give it like a natural language query, and then kubectl can do things with it, like what nodes are failing right now or whatever. And so that's one place we could see things happening, is more and more tools do that. The other thing we could see is terminals becoming more AI and agentic themselves. Warp is an example of that. And then also, the most common shells today, absent the terminal, are Bash and ZSH. And one of the things I've been thinking a lot about, and I did a prototype a while back, and my team's done another prototype, which is even better, which is like, could we create like an AI-aware shell? And each of these are ways of interacting, right? Just like you could have a desktop app that understands things and you interact with, or a web page, right? Like there's likely all of these things will happen, is my guess, because they all have interesting use cases.
How do you think about that kind of handoff between the CLI and the IDE and maybe some other surfaces where I want to use these?
Yeah,
agents? Like the last time we talked about the integration between Gemini CLI and Z, if I remember.
Yeah, exactly.
Right? So yeah.
And let me actually, let me share my screen again, and I'll show you. This is like a thing. I'm seeing this more and more across all the tools, but it's really interesting to see. So let's see here. If I'm in VS Code, like I said, this works with Z too. I can just start the CLI, and in the terminal that exists here in VS Code, right? And of course, this is working with more and more IDEs all the time. And then I can say things like, what does this file do? Like it knows what files I have open. Mm-hmm. And so I have mod.rs open. It knows that, right? It's going to read that and then send it and, tell me what it is. And so you don't have to like think of these as even flipping from one thing to another. You can actually use these deeply in concert with each other. And I think that's like, we'll probably see that being the workflow a lot of developers prefer.
Mm-hmm. Makes sense.
I'm curious again about programming languages, and are you seeing, if we're talking about the evolution of the terminal, right? There's the evolution of lots of other things that are associated with the terminal. Mm-hmm. And with generative AI, you can, like you said earlier, you don't really need to know Rust very well, right? You can use the machine to help you put in, to generate the right code. But is there a shift in like how we're thinking about code itself? And and then with that, how do you see the evolution of new programming languages?
Mm-hmm. This is a fascinating question, because I think there's a wide variety of opinions on this, and no one knows for sure. And I have generally, I think, a very optimistic opinion that's probably in the minority. But Aether was, of course, an example of that. I think we should be building programming languages that are designed for LLMs where we never look at them, so to speak. Like, I think we can get to a place where, as a developer, I'm no longer dealing with lines of code. I'm dealing with the system design, the architecture, the user interfaces, all those kinds of things. I'm crafting it together. But the actual language underneath is just a black box to me. And this, to me, feels like a natural progression of abstractions. We originally started with punch cards, right? Essentially machine code. And then we had, languages like C, which were, thinly on top of things like assembler. And then, we went to more and more abstract languages like Java, right? Or C#, which, continued up the abstraction level. And I think the next abstraction level is essentially my intent, what I want, and how that, composes together to make an experience, to make an application. And in those cases, I don't think, you'll necessarily need to have the code. Now, I always think there'll be people whose craft is the code, who love writing code, line by line. And honestly, they'll probably have a competitive advantage for certain avenues, certain areas of code writing, for a long time. And, and if that's what they enjoy, I want them to enjoy it. But I think we're going to get to a place where we don't see that, as much. And again, controversial opinion, I'm sure. But, there was a paper I read not too long ago about someone put two agents in communication with each other. And over time, they started sending gibberish to each other because they negotiated a highly compact language that they invented on the fly to talk. And, that kind of thing is fascinating to me. I'd love to see where that goes.
Is that abstraction layer by default natural language, though, or is it kind of a meta programming language? Because you want some degree of precision, right? Which natural language isn't, at least English isn't always good at.
Yeah, I mean, this is a question I ultimately don't know the answer to, but
that's why I asked it.
Yeah, I used to be. I used to be kind of anti-natural language. I felt like there were going to be other metaphors for interacting with AI that was more precise than the natural language. But as I've worked in this field longer and longer, I kind of feel like, when you look at a textbook or any a nonfiction novel, we don't worry about the precision of what's been written. No one ever says, well, that that textbook on calculus was imprecise. We feel like it was pretty precise. And of course, there's bad writing that's vague, but I think there's just so many examples of people in natural language writing precision and doc language. And I think that because you have to kind of meet people where they are, right? And people could learn some other syntax, right? Something that is formal that allows them to talk to an AI, or something that's visual that allows them to communicate with an AI. But then we're asking people to learn something new and do something new. And I think we just have more and more evidence that just have really good writing skills and have really good, have the ability to decompose problems well and understand designs, right? Like, design patterns have existed for a long time now, and they've always turned out to be incredibly useful, and not just in coding, right? Like, architects use design patterns. I think that's kind of where we want to go, is let's just help people be better and better writers, right? And better problem solvers, which again, is about decomposition of the problem.
Yeah, a different kind of skill, though, from sometimes the skill that programmers have today.
I would argue that's not true. No, I don't think that's true. I think that a great programmer is a great writer. They write down what they're going to do. They document the problem, the solution, options for the solutions, the design, all of that stuff. I think great programmers do that. And then, and they certainly understand they're able to go from business problem to technical solution really well. understanding what requirements are, understanding what's possible, decomposing it into small pieces so that they can kind of iterate and pivot around as they need to. I think those are the exact skills needed in this agentic coding world. And maybe or maybe not, the ability to write lines of code is the one that is not as needed in the future.
Mm-hmm.
So I just would like to, just ask a question about what are you seeing as the trade-offs for using, like, for instance, systems that depend on inference, because when you're depending on a system that uses inference, there are some limitations, and you're basically relying on machines to form conclusions. How do you address that?
I guess could you elaborate a little bit more? I think I'm not quite getting you.
Well, I mean, AI can essentially be a black box, right? We can't trace how an AI reached its inference. And so, when you're thinking about that and kind of in your work, how are you approaching that, really that known inherent weakness that comes with using AI tools, because they're following patterns, they're not doing reasoning. Agents are trying to do some reasoning in itself, but now you've got to set up a whole system to make sure the reasoning is accurate.
Gotcha. Yeah. I think there's a couple thoughts I have about this. One is that in terms of the black box piece, right? We don't know what's going on inside of them. There is in fact a lot of research going on that's essentially kind of like an MRI on an LLM to like show you the circuits, so to speak, of what's being activated during token generation. So we are gaining more and more insight into kind of like how they work, if that makes sense. But the other thing is, like, if I'm working with another programmer, I don't really care how their brain works, right? Like, I don't need to understand the neurochemistry of their brain. What I need to do is be able to communicate with them effectively and clearly, and for them to be able to do what they're doing. And if I kind of humanize AI, well, hey, I just need to know I can communicate effectively and clearly with them, and they can do what they're doing. Now, there is, of course, you're kind of hitting on it. We need ways to kind of evaluate and understand how these systems are doing, so that as they're in production and doing things, like, are they doing the right thing or not? Are they going off the rails? And there's a bunch of techniques that we're creating in the world. I think we have a long ways to go here, because it's far beyond, of course, just like HTTP errors. It's like hallucinations and whatnot. I will say that I feel like a lot of these are happening less and less. I think the teams working on inference, the teams working on the models, have done a pretty good job at creating more reliability. But we do need to create new techniques, both like during, let's call it CI/CD or A/B testing rollouts, but also just generally in production, for how we sample the work and make sure that it's just, like I said, not going off the rails.
Let's bring it down maybe back to the CLI itself. And I just want to talk a little bit more about Gemini CLI too, and kind of the state of things there. Like, what's new there? And to some degree, like, does it feel like a solved problem right now? Like Gemini CLI, you've got the CLI, it talks to Gemini. Is that kind of where we are now, and that's the end game?
Yeah, it does not feel like the end game. I think we're in the first inning, or maybe we're just warming up and the game hasn't started yet.
Okay.
There is certainly the basic thing that we need. It works. I can talk to Gemini and it will respond to me in a conversation using tools. And it's good enough about reasoning around what tools it needs and so on and so forth. But there's so much more we need to do around that. Models are going to get smarter and smarter. And I think some people believe that the models will get so smart that we can always have like a thin wrapper, the agent code, so to speak, around it. I think actually we'll always have more and more interesting things to put there in the wrapper, and some things will graduate into the model. And I think they come in a few different categories. One category is just UX, right? Whether you're in a CLI or some other agentic app, right? Like inside of an IDE, how you do it, right, is interesting, and like how you tell it things, how you approve tools, or how you spawn a sub agent. Those are all like, those are interesting problems that we can iterate on and make better. Do we even need chat always? Is chat the right way to do these things? I think we kind of fell into chat and it works okay, but are there other UX paradigms that we could be looking at? And then I think there's just like the next piece is how to tackle bigger problems. And there's like, there's sub agents, right? There's things like conductor, how we decompose problems. I think there's a lot of work we can do there. And then there's things like monitoring my runtime system and gathering that data back to me, right? Which is very much like a data processing issue. I love to use Gemini CLI to write my code, check it in, run CI/CD, and then deploy it, right, to Cloud Run or something, and then have it across that look at the data that's coming back to tell me things. So for instance, I'll tell Gemini CLI, use GH, the GitHub command line tool, to monitor the checks, the actions runs on some pull requests that I worked on with it until it passes. And when it fails, automatically fix it, and ask me if it needs help until the pull request fit works. And then the next step after that is, okay, let's say it's in Cloud Run, download, using the G-Cloud tool, download the logs, right? And even send up requests and see if the right things are happening. And if not, make those changes. And I think all of this is like workflow issues that we can still invest a lot in. And certainly with Gemini CLI, those are areas that we're doing a lot with, right? We're doing a lot with UX. We're doing a lot with workflow. We're doing a lot with optimizations, make it faster, all of those kinds of things.
How do you think about the relationship between Gemini CLI and kind of the background agents we're seeing a lot of at this point? Those two working together, because to some degree in the CLI, I'm still in that mode of watching the Gemini do its work. Right?
And we'll release soon. And we have, I think, in a branch, the sub agents, right, where you kick those off. But already it's very easy to use the CLI as a background agent. And I often will have the CLI spawn another instance of the CLI and then monitor it as it does something. And this is like, I think, a common pattern. And of course, we're making that better from a user interface perspective. And I think that will be more and more how it works. And I think that's a place where we can probably leave it to the Gemini CLI to figure out how much does it need to do with these things, right?
So how are you monitoring then the sub agent then?
Every CLI tool out there is building this kind of infrastructure where they can, kind of have some command that gives you then lets you look at what's going on, like the chat transcript and all those kinds of things. The systems I've built before those existed, and I kind of still use because I like them, is I give a prompt to the other instance. In my prompt to the other instance, when I describe what I want to do, I also tell it to update a file with its status. And then the one that spawned it, I have given it a prompt that basically says, look at this status file every now and then. Or, I have like a custom / command that says, look at this, status and whatnot. And a lot of these things, like I said, there are product features that are, coming and already exist a lot of the time for these. This is actually, what's really interesting is Gemini CLI is an open source project, right? And, not all of our competitor CLIs are, but I think it's been really nice because then we get ideas like this. I've seen quite a few really cool, sub agent, PRs and discussions come along for people that, again, you could, run it in a branch, which is great if you're, in an OSS project, or that feeds into what we, think is the final kind of official version. And there's so many different ways to do this. So that's why, kind of a superpower being open source, because you get to iterate on all these ideas.
And a large part of Gemini CLI is probably now written by Gemini CLI to some degree.
Sure. It was pretty early on in its development where we were able to bootstrap and start doing that. Certainly, I was coding on it pretty early on, and most of the code I wrote for it was using it. There's parts that we didn't, either because, it wasn't as capable yet, or, we just really had like fine-grained details that we needed to figure out. And there's some developer preference, but as you can imagine, essentially the whole team is using the CLI to build the CLI on a very regular basis.
So does the CLI then better understand the code context too?
Yeah, the CLI, I mean, you can generally, people manually give the CLI code context that it cares about, right? You can just at some file. Like if I'm working on something, I might say, look at this file, and then I use the at symbol to kind of IntelliSense to the exact file name, and summarize it for me, and then write a unit test. And at that point, once it reads that file, it's in the context, and Gemini has this huge context window, so it's kind of always there. But also, you can just tell it to do something, and it will determine. It'll look at readmes or overview files. It'll do ls, on different directories, and it'll decide which files to read, and then build up its own context. So what's interesting is, as an industry, we need to do a lot more around context management. I don't think models are incredibly good at their own context management, and I think that's something that for quite a while we'll need to continue to iterate on tools, because the bigger your context gets, the more things can go off the rails. And so we can give the user, developers who are using Gemini CLI, the ability to craft the context, exactly what's in there for any particular task. And that's where sub-agents are actually super useful, because you can give them exactly what they need for that very specific task. But I think that's a set of innovations that we're going to see a lot of, to more user control over exactly what's in the context.
Now, does this bring up issues around state and state management, and how you think about state and state management, and then how why you might need better context? So because this can get into some pretty challenging technical situations, for instance, with thinking about the overall infrastructure and how it's managing state across, a distributed environment.
Yeah, that's a great question. Because when you're building a project, right, you have the whole SDLC, and you have to manage, like you said, the state of that pipeline, right, all before production. And that's where I think, I like to, for instance, have a status markdown file. And I think, there are MCPs that, store it in different ways. But this, again, is another place where, I might have a set of repos, a large team of developers, all using AI, and we need a way to coordinate them all together so that those agents know what they need to know. And maybe there's even master agents who kind of understand everything. And I think we're kind of early in the industry figuring out what that should look like. But we are seeing rapid progress. I think, my team's done a lot of good work around, for instance, AI generated, but also AI consumed documentation, which really helps a lot. But to your point, it's not static, here's how things look right now. There's the need to, there's a need to understand what your deployment topology is, right? There's a need to understand, what the load is on your service. And so all of those things, I believe we need to continue to iterate on, going back again to why Gemini CLI is in the early days, along with all of our competitors. This is a place we really have to iterate on. So it's a really good insight.
Thank you. It's curious to me, because then that gets into all kinds of questions about, the processing that you do, and of all those agents that are, might each have their own state, and and then that gets into the questions about, what kind of infrastructure do you really need to do this? And it seems that's where a infrastructure provider like Google, is really almost required for this kind of thing, because who else is going to have the processing power to be able to manage agents in such a form and fashion?
I think you're right. I mean, I'm at Google, so maybe I'm biased, but it's one of the reasons I came to Google was because I thought Google had everything from the TPUs on up to do an amazing job here. And really,
but it's also the cloud service providers, really.
Yeah, others for sure. But you are right. We have in GCP, we have something called Cloud Assist, and there's an investigations feature where you can literally go to that and from, say, when you're looking at logs and say, what's this error? Or, hey, my users are reporting a bunch of 500 errors or something. And it will use AI to gather a bunch of context about the runtime environment to help you diagnose the issue. And it'll look at both like, environmental things that are just with GCP in general, but a lot about your environment where you have code running. And this is exactly what you're talking about. Like, you need a cloud provider to pull off that kind of state. And but when you have it, the agents are so effective. Right? It's amazing to me how, every time I want to troubleshoot an issue at runtime, just how easy it is when you have, using Gemini and using investigations and the way it gathers the state, and then it always knows what the problem was. It's actually, it might be like I think we're sleeping on it. It might be the use case that works better than anything else right now.
Wow.
Interesting. Well, let me switch gears a little bit as we're coming up on time here. I know you've been really interested. You talked about it as we were chatting before the show here about using these models for science and math and kind of those kinds of problems as well, where some people would say maybe they're not even that good at them yet, but always getting better, obviously. But where does that interest come from for you? And kind of where,
I'm a big math and science nerd, and I'm always looking at new ways to do things. So one of the things I've been spending a lot of time on in the last couple of months is using Gemini to do like math and science, like paper writing and research and formal verifications and things. And I'm by no means an expert, but there's lots of scientists here who can help me. In fact, I can show you an example. I'll share my screen. Let's see here if I have it open. So here's an example of a paper that I wrote with Gemini, and I use something called co-author, which I'll talk about in a second. But it basically, it does a lot of LaTeX management, and it does like code to do modeling and to make figures and things like that. But then, you
LaTeX, maybe for those who are not in scientific publishing.
Exactly. Yeah, exactly. But then in the end, I have a paper here, right? Like
that's crazy.
On error correction effects with black holes. And, this was not vibe coded, but this was iteratively built with Gemini and with experiments and, like I said, formal verification. And the thing I built to do that, I'll share that with you, is called co-author. And let me see if I can find it real fast. Here we go. So co-author, and I'll close this. It's basically a set of prompts here and playbooks for how to do things, along with handbooks on like how to use LaTeX and how to use Lean. Along with user guide and code style guides, very similar to Conductor. And then I actually have a script here, to install it. And then once you install co-author, you call co-author, and it calls the Gemini CLI to actually control it. So instead of me just like being in Gemini CLI and trying to do things, I run the co-author command. And it then figures out a bunch of context that it feeds into Gemini CLI when it starts it. And then I can resume things and all that kind of stuff. And I think that's like a really interesting way to go. In general, I think with science and math, there's been a lot of work on how can we be autonomous? How can we create like an autonomous scientist? Which is, I think, interesting. But in the coding world, we didn't start there. And there's a lot of similarities between science, math, and coding. In the coding world, we started with, like I said, code completion, then chat with tools, and then semi-autonomous and starting to see more autonomous agents. Science and math needs to kind of go through the same thing, where we incrementally build up on it. But it's very clear, both from the work I've done, but others, that Gemini CLI is a very useful tool with this kind of thing because it's interactive. And you need that interactivity before you move to the completely autonomous one-shot idea.
Have you seen a paper yet that was accepted after peer review based on co-author? Have you submitted a paper yet for?
No, I'm not. I don't feel like I'm a scientist, to do this kind of thing. So what I'm interested in is the process, right?
Yeah.
Not so much like I'm not going to invent new science or math.
Well, there's gonna be an agent symposium someday where all the attendees are agents and all the presenters are agents and they're presenting their papers that they've generated. I mean, it's
I would not be surprised. I would not be surprised at all. There is like I do know that various journals have varying levels now of AI input into the creation of the paper. And generally you have to, like in the acknowledgments, note how you used AI to build it. And, I think there's some journals want, very little, like they're explicit that, hey, AI, if you used AI to like, touch up your writing and whatnot, it's fine. Other ones are more broad. And I think we'll see more and more broad ones. I think, relatively like that paper I showed you, it was very much like the AI did everything. I directed it along the way, just like I did with Ether, the programming language. But, it was very interactive, at the same time. So I assumed that physicists and mathematicians who like I said, I'm working with them now and they're, starting to use these tools. They'll be able to accelerate their work versus just hand it off. Because I really do think that maybe someday there'll be independent autonomous agents doing science. But why not make scientists and researchers and mathematicians more effective now, right? Like that would be great.
So waiting for the moment where we're standing around at an AI poster sessions with our beers and the robots will explain their papers to us.
I can't wait. I think that would be, I can't wait for that. I think there's just so many cool things that can go on with.
And then they'll drink their motor oil.
Well, it's what the robot folks always tell you is the robots keep breaking down, and it's why they can't make progress as fast as they want to. So
it'll bother us once entertainment is heavily AI dependent, and then it's breaking down because we really like our entertainment, right?
Yeah.
You're going to see more and more of that. Like the comic book creator, right? Like, it was like kind of hard for my fiance to put that together, and then now it's a lot easier, and but we'll get dependent on these things, not just for comic books, but for video content, right? And audio content and all kinds of things. And the more dependent we get on them, the more reliable the systems better be.
Absolutely. Now we've got we're pretty much up on time here. We've got one question in the audience. If you have time for it, we'll just take it.
I got time.
You see it down there in the
we'll
cut this out of the podcast later, but the impossible computing that you've talked about at some point in the past.
That's a good question.
It is, and it's from Joshua, so maybe you can address that.
Overall, how much of an impact do you think full vibe coding will have over the next year? When I say impossible coding, by the way, I mean it kind of aspirationally. I like to say that I like to use the term because I want people to not think anything's impossible, right? That we can do anything with code, essentially. Now, the question is, how much of an impact do I think full vibe coding will have over the next year? I think that really the question is what's meant by full vibe coding. But I do think there's a world where knowledge workers and consumers vibe code ephemeral apps, a party website for a single birthday with, people RSVPing or whatever. And they're just ephemeral and they go away. But on the knowledge worker side, especially, I could see people vibe coding, say, business apps for themselves, right? Like using Gemini Enterprise, a marketer creates an app to help them do copywriting. And I think that, we'll see a lot of those. McKinsey said there's something like 100x software demand for supply. So that's a lot more programmers or a lot more efficiency we need. So it'd be great to have people, those knowledge workers, for instance, like those marketers, be able to build those things. And then we need to make sure that, there's a handoff, right? If the marketer builds some cool app, at some point, IT and the internal engineering team will need to take it over. And can we use AI to make that better from step one? Like capture the intent that went into what was built, all those kinds of things. Because we saw this, right, with like Excel spreadsheets in access databases, right? Like in the 90s, people without much technical skills or none would build all kinds of sophisticated tools. And then those tools would become some line of business app. But oftentimes they just had to start over. And maybe we're in a world where we don't need to start over every time.
Or maybe we're in a world where you want to start over every time because you just
recreate
that app without bothering, to even save it and just
Right.
rebuild it every time.
That's true. Like, your desktop OS in the future might just dynamically create the user interface for everything you're doing on the fly all the time.
Yeah.
Actually, who knows, right? That could easily be how it goes. But I do think we're entering a really weird world that's exciting on this kind of thing.
For sure. One thing I was thinking, just as a final question, I was looking at your old blog from 10 years ago, and you talk about impossible computing there, but you always had reading recommendations back then. So I was wondering, what are you reading right now? Is there something in science, math that you're reading? Any recommendations for us?
I use Kindle. I'm going to look at because there's a few things, and so I just I never remember the Shards of Earth by Adrian Tchaikovsky is a novel I'm reading right now. I'm about halfway through. It's been pretty good. I enjoyed it quite a bit.
You're a Tchaikovsky fan?
I haven't read.
I never got into his stuff.
I haven't read a lot.
It never clicked for me. So
I think this is the first novel of his I read. I recently read 7.5 Lessons About the Brain. That was really good. And let's see, what else have I read real recently? Scott Meyer's work is always really good. I think a lot of people liked The Fourth Age. I think that was really great. I reread last year John Rawls' A Theory of Justice. That was really interesting. I think I have a pretty broad reading. I would say that the most amazing book I read in the last 2 years is Tomorrow and Tomorrow and Tomorrow.
Oh, that's great. Yeah, I love that.
I got it as a gift, in fact, for my staff, I think last Christmas. It is, I think if you're a creator, if you're someone who creates things, for your job or whatever, and you work with people to do it, it is the most beautiful novel I've ever read that captures the spirit of it,
And it's just you laugh, you cry. It's such a good story.
Yeah. That one I recommend that to everyone right now. I think it's the best book I've read probably in 10 years at least.
I would say so myself. Yeah.
All right. I've got something to do on my 10-hour flight to Berlin for next week, so I'll just take that book with me.
Yeah, you'll love it. You'll love it, Frederic.
It captures the spirit of being on a team and creating so well,
and relationships, and the between people, and and what they mean and how they transform, and it's just so cool.
Yeah, it's a stunning book.
On that note, I think we're out of time for today. We're well over our time, I think, but it's a really good conversation. So
yeah, thanks, Keith.
Of course. I've thoroughly enjoyed it. Thanks for having me on. And for everyone listening in or watch this later, always feel free to ping me if you have thoughts, feedback, ideas. Keith Ballinger at google.com. I'd love to hear from everyone.
Awesome. Thank you, Keith. Alex, thank you as always.
Thank you.
We'll be back next week? I'll be traveling next week. We'll have a rerun or something pre-recorded next week, I think. So thank you, guys.
Thank you.